Hi, my name is Ben, by the way. Thanks for having me. Thanks, FirstMark, for hosting me. And by the way, just a quick plug for Lux, because we are one of their portfolio companies. I will say they are the real deal. A lot of VCs talk about taking risk, but don't really do it. And Bilal actually does, and so does this whole team. So drones today, how many people have a drone? Raise your hand if you have a drone. It's amazing. Every time I do a talk like this, the number of hands that go up is increasing every week. But most drones today are used for aerial photography, usually for some kind of recreational purpose, taking a picture of your buddy surfing that epic wave, but it could also be taking a picture of some industrial facility, some pipeline, some power line, cell phone tower. Farmers are using drones now to monitor their crops. We're already seeing improvements in crop yields from regular, weekly sort of inspection of the crops, changing the nutrients, changing the watering, so forth. And there's lots of public safety uses for drones today. Police departments are using these to keep track of their officers when they're on foot pursuits, and fire departments are using these to look behind burning buildings before sending firefighters back there. So there's some really good uses for drones today, and as Bilal said, we know about millions of flights happening each month. But I'm really excited about the future of drones. As drones move toward autonomy, I think we're going to see all kinds of really incredible, valuable use cases for people in their everyday lives, and that's what got me excited about entering the drone space. Real quick background on me, just to give you a taste of why I got interested in drones. I started flying airplanes when I was a little kid. When I was 10 years old, I grew up next to the Santa Monica airport, fell in love with airplanes, and when I was 13, I started volunteering for a nonprofit called Angel Flight. I'm still a volunteer for them. And Angel Flight flies people in medical need. It's a group of 1,500 volunteer pilots that fly people in medical and financial need to treatment centers. And when I started volunteering there, I realized really quickly that most people didn't really recognize the power that flight could offer them. We think of aviation as going to JFK, getting on the airliner, we're in LA 6 hours later, and that's aviation for my life. But actually it has so much more to offer people, and I've really made my life, my career, my personal and professional passion pursuit about finding ways to make aviation more valuable for more people. So this is me, almost 5,000 hours flying different things, having a lot of fun and doing a lot of cool stuff. So December 17th of 1903, the Wright brothers made their first flight in Kill Devil Hills, North Carolina, 100 and whatever it is, 13 years ago. And I think most people would have thought you were crazy to say that just 50 years later you could fly across the country in 6 hours. When the Boeing 707 came out, the first commercial jetliner, it took a transcontinental journey from 6 days on the train to 6 hours in an airplane. And that was only 50 years after somebody first flew on an airplane. And today we take that totally for granted, right? It's no big deal to take a red eye to New York or whatever. But what I'm really excited about is bringing the magic of flight into people's everyday lives. And we talk about package delivery being one of those capabilities that will be here very soon. And if you can deliver a package, you can deliver a person. So flying cars are not far behind either. And you don't need to take my word for it. You can trust Uber as well. If you haven't yet downloaded their white paper, I highly recommend it. Uber.com/elevate.pdf. And Uber makes the argument that flying cars will replace terrestrial vehicles and be much more efficient, much safer, less expensive, and a better experience for riders in the time frame of 10 to 15 years from now. But in order for drones to become a part of everyday life, they have to know how to navigate safe and efficient routes in real time and change according to dynamic conditions as they fly. We call this computational airspace. And so, Bilal mentioned that he felt one of the sort of hindrances to the industry was the regulatory environment. I would actually argue that there are a number of technologies that are yet to be fully baked that need to come about before we can really have scalable, reliable, autonomous operations in shared airspace, collaborative airspace between flying robots. And that's what computational airspace allows. When we have technology like this that's finished and proven, regulators will come on board and agree for these operations to happen. So let's imagine a drone flight. Say you're flying from point A to point B. Let's pretend it's a package delivery flight. and I want to take off from my Amazon distribution center at point 1 and deliver a package there at the endpoint at the AirMap headquarters. Along the way, what are all the things that I need to know to help me navigate safely and efficiently through the airspace? First of all, there are regulatory constraints, things like airports and heliports and controlled airspace and military airspace. Some of these things are quite dynamic. Let's say, for example, that a medical helicopter is going to land on the highway to pick up a patient from a traffic accident. The highway patrol may want to block off that airspace temporarily to create a safe environment for the helicopter to land, right? Of course, I don't want to run into any obstacles, so I should know where the buildings are. If there's some temporary obstacle, like a Ferris wheel that comes to town for the county fair, that's something that's important for me to know about. I should know about the other drones and other manned aircraft. Don't want to hit those. And things like microscale wind is also very important for calculating an efficient route. You know, if a drone's maximum forward airspeed is maybe 40 miles per hour on the high end in a lot of cases, and I have 20 miles per hour of wind, if that's a headwind, it's cut my performance in half. So the winds from one street corner to the next are really critical in estimating the most efficient route. And you can start to imagine all of these other dynamic conditions that would affect the safety of the route. Where are people standing on the ground? Where is there terrestrial vehicular traffic? All of these things will affect the safety and the risk of any particular flight. So what do we need for millions of drones to operate billions of flights? This is a diagram from our friends at NASA. NASA has spearheaded something called the Unmanned Aircraft Traffic Management Research Program. But you could kind of just see how a flow would work. You know, somebody gets an order for a package. The operator puts in this order into a machine. The drone wants to take off. It checks a unmanned aircraft system support service provider for a oh, I have a laser pointer, look at that. For all the constraints it needs to know for its planned flight. It checks if it's registered. Okay, it comes up with a flight plan. It's going to publish this flight plan to a unmanned traffic management system so that can be shared with other operators in the airspace. And then as it flies, it may need to deal with some contingencies. For example, a loss of a control and command link. Perhaps there's an emergency responder coming into the airspace which will take priority. So you need all of these kinds of real-time inputs as well, and then the flight is completed. That's sort of the autonomous future. I'm going to kind of roll back to present day, and we'll talk about how companies like AirMap are creating the groundwork for that autonomous future and fulfilling a lot of the demands in the airspace that exist today from, you know, sort of manually operated line-of-sight drone operations. So this is sort of just a use case for flying near an airport, let's say. If you want to fly near an airport for a recreational purpose in the United States, you're required to give a notice of your flight to the airport. You don't need authorization, but you need to give notice of your flight to the airport. And that's within 5 miles of any airport. We're also working with the FAA to create a system of authorization for flights in controlled airspace, which was required for a commercial operation. So a little bit higher standard, a little bit higher requirement, and we want to make sure that these types of transactions, requesting authorization, obtaining authorization, can be done digitally. So you can imagine a platform service provider like us bringing in all kinds of data about the airspace, serving these capabilities through APIs and SDKs, which are consumed by drone manufacturers and application developers down here. They use this kind of data for geofencing and things like that. And when the drone intends on making a flight, it's going to create a flight using a flight API, and then one of these airspace managers can see all this data on their dashboard. It's pretty simple. So this is sort of an early use case, a foundational element of what will ultimately become a more robust, autonomous architecture in the future. And just to close, I'll kind of show you what this looks like for the operator of the unmanned aircraft. Here we're showing how you can get alerts of information about manned aircraft that are coming close to your area of operation. Again, this is served through our API. And then this is a close-up view of what the airspace manager sees on their dashboard. This is Portland Airport, for example, which uses our dashboard. So they can see where all the drones are flying near the airport. They can see the contact information for operators who have opted in to share that information. And what you don't see here is a capability to set temporary rules. So for example, if there was a traffic accident, on the highway here, the airport could, in just 2 seconds, draw a little shape around there to temporarily restrict that portion of the airspace. Here's my contact information if you'd like to get in touch anytime. Love to chat with you and happy to take any questions.
Very cool, thank you. So where are you in the process of implementing all of this? I mean, I guess it's a moving target, there's regulation, and there's, how do you get sort of customers and manufacturers and institutions to all work together to make this future happen?
Yeah, so our approach is really to deliver value to customers who want this now in some way or another, right? So as an example, DJI approached us. DJI is the world's largest manufacturer of drones, and they approached us about a year ago, actually more than a year ago now, to help them with geofencing certain sensitive areas. They didn't want their drones flying over airports. They didn't want their drones flying over prisons, over nuclear power plants, these kinds of areas where it could create a bad incident, right? So we help them solve that problem by providing them with a accurate, dynamic data set of all of these types of critical infrastructure that they wanted to protect. And that is a starting place for moving forward to a more autonomous future. And it's similar with the airports. We now have 125 airports in the United States that are using the dashboard because they want to receive a digital notice of these flights. Before they could accept digital notice, it was a drone operator calling them on the cell phone and saying, "Hey, Mr. Airport Manager, I'm going to fly my drone, on the 7-Eleven at the corner of Anytime Street and what time is it now Street," and the airport manager would say, well, "What does that do for me? I don't know where that is, right?" So here they can see it on a map, and it makes it super easy. They can provide alerts to manned aircraft pilots that are flying nearby, that kind of stuff.
Okay, very cool. One question here.
I think the UTM recommendations from NASA are only coming to the FAA around 2019, which is basically the precursors for real autonomous flights and beyond vision line of sight. What's your, how far do you think we are in terms of a year where we really start to see autonomous flight? Forget delivery, but for agriculture and all the other things we've been discussing as an industry, when do you think it will come?
I think that it's already here in some cases. Okay, so it depends on the operating environment, right? So in Rwanda, there's a company called Zipline that's already delivering blood to out locations that are hard to get to by car. So there's an environment where there's relatively few obstacles, there's relatively few aircraft operating, so you don't need a super high level of assurance that the mission will be completed safely, and you have really a dire need for the service. So there's really an incentive to bring it there faster, right? I think you're going to start to see similar things happening in the United States in more rural locations. So we already see some level of autonomy in drones that are flying for farming. For example, if you use the Drone Deploy app, you can just hit go and it will fly the mission and land. If it needs a battery change, it says change my battery, and then it goes fly some more, right? So there is some of that happening already. So I don't think that we're going to see kind of like a bright line. Okay, 2019 is here and now everything's autonomous. I think you're going to just start to see more and more of these types of operations over the next few years.
All right, since we're at the end of the speaking portion of this, and you'll be able to talk to people right away. Well, thank you very much. I appreciate it.